right, so in looking at this question, which is question number 48, the first thing that we notice is where is my variable? So my variable is in the exponent. So we have an exponential equation. So the first step of an exponential equation, regardless of what method you use, is always to look for the base plus the exponent is all by itself. Now, if you look at the base here of 2 to the exponent of x plus 8, I always like to circle it. Base plus the exponent is by itself. Now, once that's by itself, you then have an option. You can either get a common base or take the natural log. Now, when you look at the base of 2, the base of 5, there's no way you're going to get a common base there. So that leaves us with this only other method of taking the natural log. So once our base plus our exponent is by itself, we then are going to take the natural log. Now, when we take the natural log, it's always on the left-hand side. So it's going to be ln 2 to the x plus 8 equals ln of 5. Now, you really got to wonder why you're going through all this effort of taking the natural log. The reason why we want to do this goes back to log properties. Because if you remember with our log properties, we had this whole property that said that a coefficient and powers, we can switch between the two. So our powers in a logarithm inside the argument become a coefficient. So after we take the natural log, the way that we make progress here is we are going to bring down the exponent. So we bring down the exponent. And the whole reason why we can do that is because of log properties. So we can't do that unless we have our log properties. Now, our exponent is 2 terms here. So we need to put parentheses around it. And then natural log of 2 equals natural log of 5. Okay, so all of that is our exponent. All of that is being brought down in front of the natural log of 2. Now, once you have gotten the variable out of the exponent, then you're back in business, because what you can do is you can say, okay, I have a linear equation here. X is raised to the first. I got to get x isolated. The first thing that I might do to get x isolated would be to distribute to get x out of the parentheses. So that will become x natural log of 2 plus 8 natural log of 2 equals natural log of 5. All right, so here's my little x. I got to get it by itself. So I might start off by subtracting 8 natural log 2 minus 8 natural log 2. Those cancel. I get x natural log 2 equals natural log 5 minus 8 natural log 2. Now keep in mind this natural log 2, all of that is just one number. You can compute that on your calculator, get a number. So I can divide, because it's x times the natural log of 2, by natural log of 2, divide by natural log 2. And that will be our final answer. So it's going to be x natural log of 5 minus 8 natural log of 2 over natural log 2. Do keep in mind you cannot cross out this natural log of 2 and this natural log of 2, and that is because you have a minus sign. So as far as simplification, that's it. This would be your final answer. Now, if they asked you for a decimal approximation, then what you would do is you would type in on your calculator parentheses, natural log 5 parentheses, minus 8 natural log 2 parentheses. So we had 2 terms in the numerator, so we need parentheses to say that that whole thing is our numerator, and then divided by natural log 2. And because there's only one term in the denominator, we technically can get away without parentheses, and so that would be our final answer, that decimal approximation, or the answer in terms of natural logs. Okay, so with this question in summary, we could not get a common base, so we took the natural log. Taking the natural log allowed us to use our log properties that allowed us to bring down the exponent. Once the exponent is down, we then distributed and then solved for x in a similar fashion that we would do without a natural log.